All right, we are here today with lesson 20 in module 3, second to last lesson in this module, and we are going to continue the work we did yesterday involving work multiplying by tens. And I'm going to show you a couple different ways to do that, one of which being the way that I showed you yesterday, using that associative property where we can multiply thing. As long as we're just doing multiplication, we can multiply in any order and get the same result. I'll go over that again. I'm also going to show you a new way with a visual. Um, and let's dive right in and do that right now. So I've drawn a couple of examples for you already, which I want you to take a look at. I'll be honest, like this isn't my favorite personal way to do it. This way confuses my brain a little bit, but that's okay. Everybody learns differently. So what doesn't work for me might work for you. For me, that other way that I showed you yesterday and that I'll show you again here in a few minutes works better for my brain. I understand it better, but for some of you, seeing this picture might help. So I debated back and forth about whether or not I was going to show this strategy, but I decided to because I think that it's important that I understand and you guys know that it's okay that everybody learns a little bit differently, and that just because it doesn't work for me doesn't mean that it won't work for you. So a lot of moving pieces here. So basically what we're looking at is 2 times 4 times 10 or 8 times 10. And so what they're doing, this 2 times 4 is shown right over there in the ones place. And I even wrote it out. This shows 2 times 4. So we have 2 rows of 4. So that part is taken care of already. Now the times 10 part is shown. I'm going to draw another arrow for you. We got like 100 arrows on this page already. That times 10 part is showed when we move this 2 times 4 from the ones column to the tens column. So we're taking this and moving it from the ones to the tens. So it's not in the ones anymore once we've moved it. Now we have 2 groups of 4 and they're in the tens place rather than the ones place. So for me, that's the hardest part of this diagram, is that like when you look at it as all in there at once, it almost looks like there's 8 tens and 8 ones, but that's not the case. Once you move them, you have to think about them as being erased from the ones column. So um, we moved our group of, here I'm going to undo what I did there a minute ago. We took this group of 8, there's 2 rows of 4. We moved it from the ones column to the tens column since we are multiplying by 10. Um, once we do that, we can think of them as being gone from they are gone from the ones column. And the result of that is that we have 8 things that are being multiplied by 10, or we have 8 things in the tens place. So 8 times 10 equals 80, or the original problem, 2 times 4 times 10 equals 80. Okay, let's look at it. That's one way to think of it, when the parentheses are around the 2 and the 4 first. So you put things in the ones column first, but there are other examples where you put um, where you start with a row in the tens place. So in this case, we would have a problem that looked like 2 times 4 times 10, right? So um, right down there, that original row, oh, I already wrote it in there. The circled part shows 4 times 10, so that's 4 times 10. I guess it doesn't hurt to write it twice to really make the point there for you guys. So that circled part shows 4 times 10. That's where that comes from. I have a second group of it though. So I take, that's just one group of 4 times 10, but this problem is telling me that I have 2 groups of 4 times 10. So I need to take another group and add it to on top or on bottom, or however you decide to do it. I need to add it to that array, basically. And once I've done that, it no longer exists in the ones place. So it says adding the red row shows 2 groups. So now I have 2 groups of 4 times 10. So I had 4 times 10 equals 40. I have 2 groups of that, so 40 plus 40 equals 80. I would prefer to solve that by doing something a little different. I'd rather say that 2 times 4 equals 8 times 10 equals 80, which is what we did in the last problem. So you're going to see those 2 problems are exactly from your, they're from the problem set. They're the first 2 problems on the problem set. The first one is done for you on the problem set anyway. The second one's not. So, but I wanted to give you a chance to go over those and have somebody explain them, because when I first look at them, they don't make sense to me. I have to really sit and think a lot about what that problem means and why is it being drawn this way. So maybe it works for you, maybe it doesn't. Do your best on the front page. If you're finding that this strategy just doesn't work for you, move on to the back side or the second page, right? So if this front way works best, the front part of the problem set works best for you and it really makes sense to you, by all means, go ahead and use it. If it doesn't and you're getting frustrated with it, move on. Go to the second page because there's a different way to do that, this sort of problem, and I'm going to show you that right now. And this is the way that's similar to what we learned yesterday. And that's like when we have a problem like 30 times 7, for example. Now, we can use the associative property to multiply in any order. Currently, the two things being multiplied to make a 30 are a 10 times a 3, right? 10 times 3 makes 30. So those were being multiplied together first. But what we're going to do is take those parentheses off there, and we're going to shift them so that they're around the 3 times the 7. So now if I do 3 times 7 first, that's 21. I'm going to multiply 21 by 10. And I know when I'm multiplying by 10, I'm going to take my 21, that factor. I'm going to take the 0 off the back of the 10 and go and add it to my 21 to make 210. So that to me makes more sense. And maybe it does to you too. But again, I want you to use whatever strategy works best for you because we all learn a little bit differently. What if I do 60 times 8? Well, I can think of this 60 as being a 10 times 6, right? Those were in a parenthesis, set of parentheses, which 6 times 10 is 60. We're undoing that, okay? And we're multiplying all of this by 8. And what we're going to do is we're going to take our parentheses off the 6 times 10 and shift them so that they're around the 6 times the 8. The associative property of multiplication tells us that we can do that. As long as we're just multiplying, we can multiply in any order and get the same result. So I'm going to go 6 times 8 is 48. I'm going to multiply 48 by 10. I'm going to get 480. You could also have a problem that looks like 10 times 9 times 2 without parentheses, like nothing's been multiplied yet, and it's up to you to figure out what to do first. Well, in that case, I would do, if I were you, I would do that first. Multiply the 2 times the 9 first and get 18. 18 times 10 is 180, right? Because we know that we take the 18, that factor, and then take the 0 from the 10 and put it on back of the 18 to get 180. Right? As long as you're multiplying by 10, you're just adding 1 0 to whatever the other factor is. So you could do that sort of problem as well, or use that sort of strategy as well. I'm just going to check one last thing on your problem set for today. Let's take a look at that together, see if there are any other types of problems that we need to work on. So let's shift our focus here to that problem set. So what I showed you in the front was I did those 2 problems for you or with you. There are 2 others to try. Again, give them a shot. If it doesn't work for you, I understand it's not a strategy that personally works well for me. Then there are problems more similar to the one I just showed you, right, where you're shifting the parentheses around. The last type is a word problem. It says Gabriella. Convenient that we have Gabriella in class. Gabriella solves 20 times 4 by thinking about 10 times 8. Explain her strategy. When you get a problem like that, it's usually very similar to the way that I just showed you. So let's do a problem like that so I can explain even more in detail. I'll use different numbers, but same basic idea. So my problem might be that Gabriella thinks about 30 times 3 as 9 times 10. Explain her thinking. Okay, that's the basic idea of those sort of problems. And when you do that, your reasoning needs to show me that, like work with the associative property, that you would say, you'd show me the work, so 30 times 3, and you say that the 30 is made up of a 10 times 3. 10 looks like a 16 there. And then you're going to, rather than multiply the 3 and the 10 together first, you're going to multiply the two 3's together to get a 9. And 10 times 9 equals 90. You should also do a written explanation to something like that that says, you could be as detailed as saying, like, you can use the associative property to multiply in any order. She multiplied the 3's together first and then multiplied that product by 10. Writing the fastest I can for you here. You could also, I mean, that would be a fantastic explanation if somebody said something like that. You also could say something like, when you're multiplying, as long as you're just multiplying, you can multiply in any order. She decided it would be easiest to do the 3's first and then multiply the 9 by 10. Something like that is also a perfectly fine explanation. So the basic point here, understanding that you can break apart that 30, you can understand what two factors led to that product, and then you can shift the parentheses onto two numbers that allow you then to multiply by 10 at the end. Multiplying by 10 at the end is always the easiest way to go. So if you can multiply the other numbers together first and then multiply by 10, that's always the easiest way to go. And you're welcome to include that in your explanation as well, saying that you want to multiply the two numbers that aren't 10 together first and make your last step multiplying by 10, because that's the easiest way to go. So feel free to use that in your explanations as well. All right, guys, I look forward to chatting with you during class. We can go over this more when we're live and in person here. And if you have any questions at that time, please bring them up and we will certainly go over them.